Hello everyone, welcome to SmartBear Academy, AlertSite 201. My name is Dana. I'm coming to you live from the SmartBear studio in Somerville, Massachusetts. We will get started in just a couple of minutes. I wanted to run through a couple housekeeping slides and some information, and then we will get started with the training with Dennis and John. So thank you everyone for joining, and if you could just confirm as well that you can hear us okay, just write it into the questions pane. We would appreciate it. If you have any audio troubles, let us know. For housekeeping, we are recording this class. We are doing something new where you will get the GoToWebinar recording 1 hour after today's class, so at 1 p.m. Eastern. 2 p.m. Eastern today. No, it will be 1 p.m. Sorry, 1 p.m. Eastern. You will be getting the recording of the class. If you share it with anyone who was not registered today, they will just have to register their name and email, and then they can access the recording. So anyone who's registered will receive the email, and anyone additional, they just need to put their name and email in, and they will get access. So we love to make these classes interactive as possible, so please add your questions into the questions pane. John and Dennis will take periodic breaks to get some questions answered, and at the end of the class, take a moment to fill out the exit survey as well, so we'd love to see your feedback. And before we dive in, I do want to just make sure that everyone understands who SmartBear is and what we are all about. So we do focus on providing software quality tools for teams. And specifically, our goal is to infuse quality and speed into your entire software development lifecycle. So I won't get into full details on this slide, but I just want to share with you what the SmartBear product portfolio covers. And it's the entire software development lifecycle, from development to testing to operations across both the API and UI layer. And our products enable teams to deliver to the best software faster than ever. So if you aren't aware of all of our other products, they're all listed here, and definitely ask any questions or any information that you'd like to hear from us. We can forward you to our customer success team, whichever that may be. So I wanted to give you all some introduction and background there of SmartBear. For the training offerings for AlertSite, AlertSite 101 is every other month, and then today's AlertSite 201 is held every other month. And after today, if you've attended both 101 and 201, you'll get your graduate certificate for SmartBear Academy from AlertSite. So keep an eye out for those later in this month. And I will put this into the chat link. This is where you can find all of the upcoming classes, so just bookmark this page. It will have links for all your registration, and this is where you can access previous recordings as well. So without any further delay, I've met myself, and we have John and Dennis on hand here to start us off with the training. I'm going to hand it over to Dennis to go over the agenda, and then we will get started. So thank you everyone for joining.
Thank you, Dana. So today we're going to focus on alerting in a little more detail than we have in some previous webinars. We're going to start off by going through some scenarios that you might see with your applications, and how those scenarios will play into alerting, the experience the app's having, and how that translates to various alerting situations, and then really what we want to do is highlight some of the key differences between availability alerting, which pretty much everybody does, and performance alerts, which is something that we think is a bit underutilized, and we're going to talk a little bit about how performance alerts can give you a heads up in some scenarios long before an actual outage may take place. So that's kind of it from a standpoint of those scenarios. We're going to dig into the performance alerting configuration, talk about how you can control certain elements of those performance alerts to get the best alerting setup for your company, and then finally we're going to discuss some alerting best practices more generally. So I think the topics we talk about in the performance alerting specifics will kind of blend into best practices, but we may talk about some things that are more universally applicable to alerting and not specifically only to performance alerts. So that's pretty much what we're going to try to do today. John, anything else?
I think you covered it well.
Thanks, John. All right. Then without further ado, if you want to make me presenter. Okay. So, on my screen, we now have a scatter plot of a monitor that's running. And what we wanted to start with was kind of the more standard kind of example and experience of an outage, just to kind of level set. Your monitor's, kind of plugging along. It's going well, and then, something, catastrophic happens in your infrastructure, and everything goes dark. And it goes dark, quickly, right? Everything's fine. It falls over. It breaks. Depending on what your alert thresholds are, what your recipient settings are, things we'll talk about a little bit later, folks get alerted. Okay, so this is kind of basic availability alerting. Not really much to talk about here in terms of how can you do something to, to get early warning in this situation. This is, pretty much basic stuff. I think, John, you called this more of a 101 type.
This is 101, right? But Dennis, would there ever be a warning, a scenario where there would be some tell sign of something happening prior to the outage?
Yeah, John.
So it looks like here it was just working, and then it's gone.
Yeah. So this is more the scenario where there's a major issue in the network or in the application servers where you just have a hard down and the application fails. And there's not much you're going to get in terms of lead time here with the synthetic monitoring that's in place. But there are scenarios where the profile leading up to a failure looks very different. And
you have an example of that?
I do, John. Let me pull one up for you. So what I'm going to bring up now is a very different scenario. This is a real-life event, real-life monitor here, and it's obviously a very different picture from what we just looked at. There's a lot more going on here, certainly, no question about it. There is some instability prior to the more significant outage, but what I want to walk you through is sort of how this event transpired and what we can kind of do about it with the tools we have in AlertSite. So we have our kind of baseline here, and what we have here is the normal behavior of this monitor, and this particular chart only lists part of the kind of life of the monitor leading up to the problem, but the preceding performance band is comparable to what we see from 2 a.m. to let's say about 6 a.m. And this baseline is now this profile is what's setting the normal performance expectations for this monitor, and things are going well, and there's no real issues. Now, starting at about 6:30. We have a very different story starting to emerge. You start to see some fracturing of the performance. You start to see monitors breaking out of that normal band of the 10-second average, in between 5 and 20 seconds. You start to see a lot of runs start to pop out beyond that band. But the application's not completely down. It's not failing dramatically at this point. It's just starting to get inconsistent, and that kind of continues on for about, let's say, about 2 hours or so, up until we get to approximately 9 a.m. and then things take a turn for the worse, right? Performance is already degraded, but now we've got significant portion of the runs for this monitor are now failing. So we are now into, an outage situation at this point. And, with availability alerts, depending on the settings that you have set up, you may or may not be alerted to any problem with this monitor until you get to this 9 a.m. point. And then there's enough frequency of failure that the majority of recipient configurations and alert settings are going to throw alerts at this point. But at this point, you're in the outage, so it's kind of too late to do anything to avoid the outage. So, so this is the scenario where there's some things happening here between 6:30 and 9 a.m. where we might be able to help out with that with performance alerts. So it's essentially setting a different threshold, a different lens, if you will, on the monitor to determine when we want to get alerted about something. So, John, any more thoughts on the scenario?
So when I look at the degradation, it looks like it was going on for over an hour.
Yeah.
Right? Yeah. So at least visually, if someone's looking at the chart, there would be an early warning indicator above and beyond the charts, right? Visually, we could see that.
Yeah. So
it's a long lead time before the outage. There's something to work with.
Yeah. So if you're looking at a dashboard, if you're looking at results in real time, then you kind of would know, and you're familiar with the app's normal behavior, right? You'd know something was up. But let's assume this is happening off hours, over the weekend, when your team's not looking at it, or it's an app you're not looking at in real time.
You're back. Sorry, you were gone for a second.
Oh, I'm back. All right, excellent. So yeah, there's clearly something going on here, and the question is, can we programmatically catch this? So so that's what we're going to kind of talk about. So we're going to come back to this picture, but what I want to do now is kind of switch gears and take a look at our alert, performance alert, and then we want to kind of backtrack into the alert configuration and walk through the different dials we have to set thresholds and create performance alerts, and then we'll come back to this picture and really look at, given a certain specific configuration, when would we actually trigger an alert. So I'm going to hand this over to John, and we're going to...
So what we're going to do now is we're going to take a look at an alert payload generated by the performance alert engine.
Hold on.
So look at that. Conveniently, this monitor triggered an alert today. This is from my demo account. It's an API call, delete item by SKU number. And what we could see here are a bunch of warnings down below, the rules associated with this performance alert. So let's walk through the rules first, and then we'll talk about the actual thresholds that were crossed over. So we're looking to grab a sample, a 10-minute sample, and then compare it against the 7-day running average. And we also want to make sure that 2 locations trigger that threshold. So again, grab a 10-minute sample, compare it against a 7-day average across 2 different nodes. Now think about this for a minute. The actual data being returned from the runs being returned, we're not averaging the runs together between 2 different cities. They're runs, we're keeping their own silos. So as long as 2 locations cross over the threshold, it's going to trigger an alert. And the thresholds are 40%.
And Jim, just to make sure folks get that, the performance alert engine is determining the threshold for each monitor for each location. So that way a location that's typically slower than another isn't going to, erroneously go into an alert mode because it's working normally, which is what would happen if you only had a single baseline or threshold set here.
Right, so each location is going to maintain its own baseline. And then we see here the 2 locations are Fort Lauderdale and Boston that cross the threshold. The actual and then we're going to see the historical difference. Excuse me. So 141% difference, where the rule is 40%, and then the other node from Boston is 81.8%. And that's a pretty dramatic change, and you may want to consider, given the difference between the performance of the historical average versus the actual current, that maybe the 40% rule, if anything, is a little on the light side, possibly. Maybe you want to raise that, because this would have been triggered even at 80%.
Yes. And we'll talk a little bit when we get to the config screens on some of the pros and cons and good starting points for that.
All right, so let's jump into the actual alerting engine itself and take a look at the configuration associated with this monitor. All right, there it is, Inventory API. First thing I see is this particular monitor is not associated with any monitoring recipient group. As we always know from the rule, if you're not associating a monitor with a group, it alerts everyone. The performance alert.
As a side note.
As a side note, just a little.
So this is an area where this default, people love it or they hate it. And you know, we are looking at possibly changing up how we kind of associate a new monitor with potentially a default recipient group, rather than sending to all recipients. So that is something we're always looking at. Any feedback on that? I've had a lot of it over the year or so that we've been talking about this. But anyone who has a real preference one way or the other, I'd love to hear about it. So feel free to drop me a line on that.
Sure, fantastic. So the first thing you want to do is you want to configure the metric associated with this monitor. For an API, you're not going to be looking at web-based timings like DOM load or page load or full page response time. You can look to default to the response time. And then dynamic versus static. For this example, we'll use dynamic. We'll look back.
John, before we get into the details of this.
Sure.
Bigger picture, dynamic versus static. This is kind of a best practice, but we said we'd bleed back and forth on that one. So when would you, I have my thoughts on this, but when would you go static over dynamic?
Sure. If your application's pretty consistent and returning, say, a page or a response, say a half a second, and it's just always half a second, it's a very tight band, you could set a static value. Because with certainty the application performs at a certain response time, and over time it's pretty consistent. But if it exceeded that particular response time, you want to know about it. Dynamic's more useful where the application performance could change over time. An example would be an e-commerce store where you have traffic at different parts of the day impacting the performance, as well as weekend versus the workday performance.
And even application changes, will change the expected performance over time.
Well, absolutely. So, a larger payload will certainly impact performance. And if you decide to put more images on the site, the performance is going to slow down, and that performance may be acceptable to your business, but the static value may no longer be appropriate to that particular monitor at this time.
So there's more of a maintenance overhead with static thresholds.
That's right. You're going to always have to go back. Imagine if you set a static threshold 2 years ago, it may be too low, it may be too high.
Yep.
Expectations change.
The other thing about static that's important to note is if you have geographic performance discrepancies, the static threshold applies to all locations. So it's generally not a good option to use if you don't have consistent results from various geographies.
A common example is a given application not performing as well from, say, Moscow versus North America. And that's a perfect example of why you'd use dynamic, because it's going to maintain a different set of metrics, response times, silo, or baseline for that city versus static, where you're going to have to set the static value really high so you don't trip over the response time from Moscow, or if you set it too low, you're going to have to get used to a lot of errors being sent to you. Now, one way you could suppress that is configuring the number of locations from 1 to 2. But the problem with that is you're basically silencing one of the cities forever.
Yeah, and I was going to say that. That's exactly right. You're effectively throwing Moscow out in this case.
Forever,
Yeah.
exactly. And then you're at the mercy of the other locations.
Yep. And then at that point, you're really only looking at 1 deviating, not 2.
Correct.
So you still might trip for a localized issue at that point.
So that's why we recommend dynamic. And there's different options here. It really depends on how frequently the monitor runs. I generally recommend looking at a relatively large sample, maybe 20 or 30 minutes. Your use case may be different. You may want to look at a more tighter sample. But what happens is when you look at a tighter sample, of course, the monitor is going to be more sensitive to thresholds.
Yeah, and just to kind of dig into that a little bit more, there are 2 variables to this, I think. One, absolutely, is the frequency the monitor is running. And you know, the more frequent it is, I think the more flexibility you have as far as going with a tighter window. If the window is smaller and the frequency is lighter, you are going to have what I would call a twitchier alert at that point. You're going to be more likely to cross those thresholds on a more frequent basis. And so it's important to understand the consistency of the applications as well as the frequency of the monitor when you're looking to set these up.
Now, this particular monitor, I got 5 alerts today from this monitor, about 3 yesterday. Would you consider that twitchy?
I would, John. That would definitely be twitchy. And I think there's kind of a positive scenario of that sort of alerting and a negative one. When you're first setting these up, that kind of alert behavior can be very valuable to help you understand that your application is not performing consistently in a way that you may not see in some of the charts and other visual things you're looking at. So it can be a positive thing. But from an ongoing standpoint, I would say that your alert recipients would start to become numb to that monitor and that performance alert.
Well, that's a single monitor. What happens if you have 100 or so monitors sending 3?
Yeah, I would say the likely scenario there is someone's going to create a performance alert folder in their inbox with a rule routed to it and never look at them. So, yeah, it is. There's a bit of you know, a little bit of trial and error and a little bit of, you know, really understanding both the application and how you're set up to receive these alerts to find that sweet spot. So I'd say, though, if you're looking at every day getting multiple performance alerts from a given monitor, it's probably set too aggressively.
Okay, fair enough. And then it all comes down to how far back do you look, right? So we have our 20-minute sample. What do we compare it against? If your monitor is consistent, you certainly can look at 1 day. I like to look at 7 days.
Yeah, I think the longer window, it smooths out some inconsistencies you might have from day to day and prevents you from getting in a, you know, that Monday morning situation, right, where if your app performs better over the weekend when traffic's lighter, the baseline then drops, and then Monday morning hits and traffic slows down a little bit. It still could be completely acceptable and normal, you know, behavior of the monitor under peak loads, but it may trip the threshold at that point. So if you're looking at a longer window to determine that baseline, it's going to smooth it out a bit, and you're going to have I think, a more realistic, you know, approach every time that result set is evaluated against the baseline.
Then we're left with our last decision, the error percentage. We had 40%, and then we had a warning. I believe it was 39.99. So the warning, by the way, has to be filled in. So I really wouldn't worry about what the warning value is, other than it needs to be lower than the actual error threshold. So you fill it in. It's not going to trigger on that particular threshold, but it does need to be completed for this exercise. Now we got 3 to 5 alerts from this setting over a period of a couple of days.
Yep.
And it looks like it maintained that trend for weeks prior to that. So if anything, I would think my error threshold is probably too low.
Yeah, I think that's probably
Right. So what we're going to do,
there, for sure.
given we exceeded it by over 80% and 100% on the error payload, we're going to raise this to 100%. Let's commit that. Some applications have multiple steps. Some applications are not a single API call or maybe even a single step in a journey to web application. So we also support step-level alerts. This particular API call has 4 individual requests. This allows you to determine the rule by each step rather than the entire monitor. Imagine a scenario for at least a web application where the login's really fast. Not really much concern there, but your customers are sharing with you, anecdotally, that the application's slow generating a particular piece of content. That's where you could focus or hone in on with your performance alert.
Yeah. The other benefit of the step level alerting is that for a multi-step monitor, the overall response time of that monitor could mask a more significant performance problem with a particular step. So if a given step is really critical, there's a lot of value in setting the performance alert at the step level. It just, it really does depend on the monitored application and what's really important. The other reason that the step level alerting is really handy is if you've got different on-call or recipient groups that are aligned with the functionality of a given step. They could be completely different parts of your organization. The step level alerting in general allows you to route alerts to different groups for different pieces of functionality within a single monitor, and that's pretty powerful. That's a more broad benefit, but it is equally applicable to both performance alerts and availability alerting.
Fantastic. Look what we found here. As we drill through the individual steps, this step has associated itself with 3 different recipient groups, as well as it's built its own performance alert on this particular step itself. This is pretty similar, if not identical, to the alert we got.
It certainly.
So it looks like some best practices are being found here.
They are. You might be a little twitchy on this one, but your other routing rules seem pretty solid.
This is where our pain is, and this is where we want visibility.
Yeah. Exactly.
All right, so we're going to talk more about the alerting engine as we go through our call today. But I believe, Dennis, you want to share with us some more feedback from some of your charts that you found.
So let's go back, now that we've kind of looked at these settings, let's go back to the performance degradation picture that we had looked at earlier. So now we're back to this picture, and let's remember those key variables, right? We've got static versus dynamic. We've got the time to determine the baseline. We have the amount of time you're looking back to determine the current performance against that baseline, and from those variables, and then the number of locations that have to be exceeding the threshold to trigger the alert. All the things that John just showed you. So if we look at this scenario now, we can kind of, I've done a little math in advance here, so I don't want anyone to think I can do this math just by looking at the scatter plot. I'm not that good. But that being said, if we take a look at our baseline here, so just to reiterate things we looked at here, the baseline itself actually worked out to be about 10.5 seconds on average. That's for the whole monitor. As we talked about, the actual thresholds for the performance alerting are being set per location. This monitor runs from 10 different locations. In the interest of not putting too much into the scatter plot, I don't have this scatter plot showing each location as a separate marker, but that is the case here. So each location has its own baseline. The overall performance of this monitor is around 10.5 seconds, which tracks visually to what that looks like on screen right now. So when we get into our initial degradation zone, which I will kind of categorize as sort of this, let's say 6:30 to 8 a.m., relatively speaking, timeline. This is the point where we have an opportunity to get an early warning. The availability alerting really falling off the cliff at 9 a.m. is obviously useful. But in this case, unlike the first example I showed where we had a hard fail of the application, in this case, we have an opportunity to get notified earlier. So let's use that 100% example for the threshold and 2 locations. And let's say we're looking at an hour, performance for an hour, and comparing that against the 7-day average. What we would find is that at about 7:30 or so, rolling into the 8 a.m. time frame, we now are seeing several locations with a average response time for the last hour exceeding that 100% threshold. And in this case, it is, and I forgot, I'm going to look this up. I believe it is New York, which is 125%, and Charlotte, North Carolina at 150%. And then we actually have a third location at exactly 100%. So at that point, in that look back now, we have put ourselves in a position where we can trigger a performance alert, right in this, 8 a.m. window, possibly a little bit earlier. But we're now an hour ahead of this outage and in a position to be able to trigger a pretty actionable performance alert with that, configuration of 100% of performance degradation for 2 locations over the past hour. So that's not a particularly, twitchy setting, to use that term. Looking back for a whole hour for 2 locations, there's got to be some pretty significant degradation going on. Obviously, if you push the envelope and go to a shorter time window, this arrow would move to the left, and you might get alerted earlier. The risk of going too far in that direction is the scenario that John showed, where he's getting 4 or 5 alerts a day. And those are not, I don't know how actionable that is. It's good to know that your app is performing inconsistently, and that may be something you want to fix with your application teams and your operations teams. And this kind of setting can help identify that and resolve it. But in terms of a real event that might be a precursor to a failure, I think the slightly higher thresholds and longer time windows are going to give it a more definitive gravity to it when it fires. When that thing fires, something's going on and something that's worth looking at.
And it's even possible the outage may never take place just by you knowing about the performance degradation hour beforehand, giving your team the opportunity to work on something before it goes down.
Yeah, absolutely. And in another alternate reality where this performance alert triggered and the ops
there would be no outage there.
To the right of this arrow would drop back down into the normal pattern, and we'd never have this problem. So it's kind of like pre-crime.
That's exactly.
In Minority Report, right? We have a chance here to get out in front of it and prevent the outage from happening. So maybe we'll work some of that Minority Report theme into things in the future. Could be
sounds
cool.
Good.
But outage avoidance, though, it is a real thing. I mean, and obviously, not every outage is going to have this this kind of behavior, this pattern. But if it does, and you have the ability to to get out in front of that outage and prevent it from happening, or at least significantly minimize the impact, that's really the benefit of the performance alerts. So, from a best practice standpoint, I think that we had a Connect, our SmartBear Connect show a couple of weeks ago, and we had AlertSite track there, and we talked for a little bit about performance alerts and thresholding and things we can do to make the product better and more automatic about baselining. But one of the big topics was about what to set those thresholds at, and a couple of the folks had even higher thresholds than 100%. They really were like, we're using this as like it'll catch really significant performance degradations, but they don't want a lot of noise in the middle. And so I think everybody's got to look at their applications, their on-call teams, their tolerance for both performance variation in the product and their tolerance for a given volume of alerting, and find that sweet spot. 100% for an hour for at least 2 locations seems like a good starting point to me. We're going to look more at baselining, and we may look to both provide more guidance on best practices going forward on this, but also I think in the product itself, I can see us doing a lot more with baselining going forward, and we may be looking to make it easier to just set automatic performance alerts across multiple monitors without having to go in and set each one. But in the meantime, for your critical monitors, going in there and setting dynamic thresholds doesn't really require you to do any math up front to determine a static threshold.
100% across the board.
Yeah. So I think that is something to think about as a starting point. Any feedback that you guys have over time about how different thresholds are working for you would be super valuable. It's the kind of thing we could come back and talk about in a future 201 session. Even share some results, share some feedback on this. One of the things I want to look at is actually a little more closely, since that Connect show and this webinar, and then going forward, how many, if there's any change in the pattern of how often people are setting up performance alerts.
Right, if you haven't used performance alerts before, as Dennis said, your critical apps, try that on a sample of applications rather than going through all of them at once. Let it run for a week or 2 and just see your comfort level of getting these alerts. Hopefully you don't get any alerts, and then you roll it out across a larger set of monitors.
Yeah, and obviously both the criticality and the behavior of your application will determine which ones to pick and what settings you want to look at. The scatter plots can tell you a lot. There's some other reporting that you can do. The regional breakdown report that gives you stats by location.
That's right.
For given time windows is another good one to look at, to kind of see the typical behavior by location, and that can help you to determine how many locations you want to include in the threshold, as well as getting a better understanding for what's normal.
So, Dennis, any thoughts regarding the number of locations that should be in the pool? Because in many ways that plays into this as well. If you're only monitoring from 2 locations,
yep. So
in its entirety,
yeah, we see a lot of monitoring that's running on a small number of locations, and actually we see a lot of monitors running from 1 location, which we very much don't recommend. We have 85 locations around the world, and even if you're for example U.S. based, it's generally a good idea to have a good sample of locations just to vary what's happening in the wild when you're running these monitors. So I would say 2 would be the absolute minimum, but I would suggest setting up your default locations to include a bigger pool than that, unless you've got very specific geographies you're concerned about. We do have that scenario as well, where it's really important to know the performance from just a handful of locations. But if geography is not super critical, then diversity of that geography is important and helpful.
Sure. All right, so what we're going to do next is we're going to look at the alerting engine, the engine that creates these alerts, and how they make it back to you.
John, do you want to go take a look at the scatter again?
Well,
or do you want to go look at the recipient?
Have another example you wanted to share.
Yeah.
So why don't we jump into that?
All right. I didn't know if you were more interested in looking at the other. So the other configurations that kind of dictate generally, from an alerting best practices standpoint, how the alerting behaves in the wild is on the recipient group and the recipient level, and that's where you can set the sensitivity for how many times a monitor has to fail before you get alerted, how frequently you're reminded when there's an outage happening, and whether you get clears or not. This is also where you can control if you get a performance alert for a warning versus for an error condition. So John talked a little bit about setting the warning threshold. Generally, until you really understand how your app performs, I would recommend setting the performance alerts on error only for a recipient. But as you get more comfortable with it and you really want to get some earlier warnings on situations where performance degrades, you can get both.
And remember, as a recipient, you could opt in for warnings or not. So
right.
Say you have a team of 20 people and you just want to try out the warnings just for yourself. You can do that without sending them to everyone. It's not all in.
Right. So what I wanted to do just is to kind of provide, a visual scenario before we look at some of those recipient settings for sort of the last part of our best practices for this session, was to look at a scenario where you've got instability starting up. Now, we've talked about the performance thresholds. If we look at this sort of first period of instability first, we've got a period of time here where we're starting to get some performance degradation, but in the grand scheme of things, unless you've got a really aggressive threshold set, there aren't nearly as many slow successful results in this window of time as we saw in the previous example.
But we do see a different behavior here, though, for the failures themselves.
Yes, so that would be the second part of this. But I don't think it's likely that this scenario, unless you've got a very aggressive set of rules with a low percentage threshold, and
possibly even one node,
one location probably, the likelihood that this is going to alert would really probably only happen if you were looking at a very small window of time, like 5 minutes or something.
Right. The sample size is too large.
Yeah.
There's just too many runs with one sample.
So one or two of these slow runs would be enough to trigger it. That would probably be a really noisy configuration and not all that helpful. But what I wanted to look at a little more closely is how the settings for availability alerting can dictate kind of when you get alerted here. And the thing to note with this scenario, and I'm going to switch over to a zoomed in view of this now that we have this sort of bigger picture. But you see, even though the failures are happening, and there's more of them than you'd like to see for sure, they're still not happening ubiquitously in any given time block, except for down here, which is a hard outage for sure. But in these other scenarios, they're still intermixed with successful results. So what I will do is bring up kind of a little bit of a zoomed in view, and what I want to kind of highlight is the importance of understanding how your recipient groups are set up, and we'll take a look at those screens in a second, but I wanted to kind of give you a little bit of a visual of the scenario from the monitoring perspective. So if we take a look even at this little block here, you can set up a recipient to receive alerts on one failure, 2 consecutive, 3 consecutive. There's a wide range that can be set there, and depending on who the recipient is and what their particular tolerance is for getting alerts, you know, a lot of our recipients are not set to one failure. They might be set to 2 or 3 in a row. And in this case, just to point out, while this might look like a scenario that would, you know, trip a lot of alerts, if you really kind of take a look at how this is playing out, if you're above 2 consecutive failures here, we've got plenty of successful runs intermixed. Even in this tight window, this guy here is breaking the consecutive counter. So even though we're starting to see failures here, unless you've got more of a hair trigger recipient set up, this scenario is probably not going to result in.
But this also plays into a different scenario we see all the time. Why do I see red on my dashboard where there's no alert generated?
Right.
And that's this scenario. Exactly.
Yep.
Right. There are successes mixed in with the failures that stop the that will stop the triggering of the alert.
Exactly. And so at any given point in time, looking at the dashboard, the current status of these monitors is going to vacillate between success and failure. That's one of the reasons we put in, for example, that availability sort on the dashboard, where you can sort the lowest availability monitors to the front. In this case, this one might always be 100%, and now it's going to drop a little bit. And
right.
so it might percolate to the top.
99.98, something's gone wrong.
Right. Even if the last run's successful when you're looking at that dashboard, this monitor still may percolate to the top because its performance in the last 24 hours is starting to, or its stability, since we're got to be more precise about our language today in this session. The stability of the monitor, the success rate of the monitor is lower than usual. Not by a lot, but by enough that it could be significant. So there's a couple of different ways we can surface this situation, but it's important to note that depending on the configuration of your alert recipients, this whole scenario on this zoomed in screen could result in lots of people getting alerted numerous times, alerts and clears, or it could be quiet, silent even, right? You might not get any alerts on this depending on how you're set up. So I'm going to give it back to John,
sure.
And we're going to look real quick at the...
Let's go to the configuration panel really quick prior to jumping to the engine.
All right. You want to go to recipients?
No, we want to stay right here.
All right. I'm going to give it to you then. You are
all right,
correct.
Fantastic. So as we spoke about before, you want to assign the step or monitor to a recipient group. Whereas here, I've assigned it to the marketing team, off hours VIP applications, and the ops team. So if this monitor did trigger the performance alert, it will not send an alert to anybody else unless you are part of that recipient group that's listed here, the 3 of them. Let me go back to the monitoring alerts here. The other thing I want to point out is the alert note. This allows you to put information relative to this monitor, and this variable can then be used in the alert payload. And a good example of that is, say you're a Salesforce.com customer and you want to monitor Salesforce.com. The triage for a monitor failing is going to be different for Salesforce, a SaaS application, than it would be for one of your own applications. This allows you to put that workbook, something as simple as the 1-800 number for Salesforce, or the hyperlink back to their customer support ticketing system, or maybe even the link back to their health page showing all the Salesforce nodes and how they're performing. Or a certain monitor that may not be as important. For example, if this monitor fails after 11 p.m., don't worry about it till the morning, because it's the travel application where no one logs on to unless they're at work, things of that nature.
So it's almost like a mini runbook.
Exactly.
You could also link to a URL if you've got more detailed instructions on a wiki or something.
Especially helpful for the off-hours team or newer employees, or if your department has a lot of churn, a lot of promotions out of the department. This allows your new employees to quickly get up and running and understand what to do next if the monitor fails. All right, let's go to the recipients now. The AlertSite platform will allow you to determine who gets the alert, in which channel of communication they get the alert, and when they get the alert. So for example, I've elected to receive an email alert, but not elected to receive an email alert over certain time periods, like the weekend, 11 p.m. to 5 a.m. You're going to make that determination. Now the blackout window is for my individual recipient. This particular email, not me throughout the system. It's not going to affect my SMS messaging or my JSON post messaging for me. It's only going to affect my specific email notifier, suppressing those alerts from going out, maybe even going on vacation. We support other types of alerts, like integration with ServiceNow, Slack, Splunk, right, other third-party solutions out there. And of course, PagerDuty, allowing you to not only receive these alerts via email and text message, but also receive them via and send them to other forms of other repositories, data collection tools. So let's go take a look at my individual recipient here. That rule Dennis was speaking about earlier. What happens if you change this to 2? This is not actually errors. It's segments in error. Segments that are in error. What's the difference? We have a retry rule. That retry rule states, upon failure, fire again. If it's not successful, fire from another region, another area within the region, right? That's called global verify. And there are, of course, certain modifications you can make to that to turn off the retry rule or not fire from another region. But if you change this number from 1 to 2, this implies it goes through that cycle twice. So if you're firing a monitor every 5 minutes, it would have to fail, go through the retry rules, stop, wait another 5 minutes, and fire again. So this would consume 10 minutes before you are alerted. So be careful with this setting. This is not individual failures. These are segments in failure.
The one thing, John, I'd add to that is you're extending the time window before you get notified, but you're greatly increasing the likelihood that there's a real problem.
Well, absolutely.
So it's important to know where your tolerance is, both individually and organizationally. You may have your on-call guys set to 1, right? They get the hair trigger alerts, and they've got to look at all of them. But you know, folks who are not as immediately involved in the hands-on operational piece, they may not want to know until it's a more prolonged problem. So there's a lot of variation in how you set these and why you would do that for a given recipient.
Then it comes down to how often do I want to be reminded the application's in failure. Traditionally, people will set this to 1 or 2, 2 being that second reminder so it doesn't roll off your email panel